Alrighty, we're surface area part 2, pyramids, cones, and spheres. Just an example of each of them. It'll go pretty quick. Again, most of the theory and the ideas have already been somewhat discussed. We're just looking at some practical examples. Oh, and look at the very cute big spider on the front page here. It was discovered, in Indonesia or somewhere. Really big spider. Not as big as the Goliath, but a lot prettier. I'd like to capture one of these and let it freak my wife out a little, maybe. I actually had a tarantula crawl on me a couple of times. They're really kind of cool. Moving on, we're going to take a look at pyramid. Now, I'm not going to get into the theory of why the formula works because we're just going to plug and play here. But we're going to look for the surface area of the pyramid. And given all things equal, with no other instruction, we're going to look for the total surface area. That means we're going to find the area of this triangle, that one right back here, and the one on the opposite side. That's 4 triangles. And then we got to find the area of this base. It's one and only base. That's one of the differences between a pyramid and a prism. All right. So we're going to add up all these areas if we want to do it, or we can use the formula. Again, there's more than one formula, but we're going to use the one that's provided by our state of Texas. And we just go right down here, pyramid. Here's our lateral, and here's our total. And the only difference is that here we're just finding the area of the triangles, the faces, and here we're finding the area of the triangles plus that rectangular base. Actually, it's a square base, because again, given no other instructions in this course, when you see something like this, you're going to assume it's a right regular polygon on the bottom, and prisms are right, and so on. So we're just going to plug and play. First thing I'm going to do is I'm going to write down my formula: 1/2 P cursive L plus B. Now let's take a look at our definitions. P is perimeter. That's all the way around this puppy. So we're going to start here and travel around. That's 15 plus another 15 plus another 15 plus another 15. So I went around, total of 60 feet. So it's going to be 1/2 times 60. Now this is one of the most important things out of all this surface area stuff, is knowing the difference between the various heights that you're going to be given, especially when we hit volume. This L means lateral height. Look how this is. Now let me draw an orthographic view of a triangle. Of that triangle right there. Here we are. Here's an orthographic view. We're going to go dot, 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 and draw my little height right here. So we could do 1/2 area, 1/2 base times height, right? To find the area of the triangle. Because this is our base and this is our height, we can find the area of this. That's exactly what this L means. This L represents the height of this triangle in an orthographic view. It is not this edge. That is the biggest no-no in the world. This edge is not my height. In fact, I have to travel a little bit further up to do that. This is my altitude of the triangle. So I put in 12. 12 right here. And the plus the area of the base. That's just length times width. When you have a squared, side squared. 15 times 15, 225. Let me write that down. 15 times 15. All right. And again, we could put this in the calculator. My handy dandy Mark I Casio. So I'm going to do 1/2 of 60. So I don't have to double type, but tell you what, I'll do the whole thing. 0.5 times 60 times 12 plus 15 times 15. Don't do this on a lot of the cheaper calculators, especially our baby calculators and stuff. They could get confused on order of operations, especially when we hit exponents and some other things. They can get messed up. Casios, they're pretty smart. Boom, 585 square feet is the total area. And if I were to paint this thing, front, top, bottom, all that stuff, I would need 585 square feet of paint. Next example. A cone. Now cones are pretty clever. I like cones. And this is something I didn't do in the classroom. I should have, but I'll go ahead and explain it real quick. Here we have a cone, which is just a round all around here. So there's no real faces. We have a circular base. And here, let's take a cone. I created this using lines, and I'm going to clone it. Cloning the cone. And watch what I'm going to do. I'm going to line it right here. And look what I created. I created a cylinder. It's the Leaning Tower of Pisa cylinder, but it's still a cylinder. If you ignore this little diagonal line right here. And what we're going to do is we're going to take the area of a cylinder, which was perimeter times height plus 2b, kind of cut it in half. Now remember, our perimeter of the cylinder was circumference, so we're going to use the circumference formula. So let's go ahead and do that. Well, I need one little thing here though. This L. What is that evil little L? That's my lateral height again. It's sliding down this thing. So we're going to have 8 and 15. Remember, we got a right triangle right here. So we got to do a squared plus b squared equals c squared. So 8 squared plus 15 squared is equal to c squared. Now, you could work it out in the calculator, but this is also triple. So I know this puppy is going to be 17. Let's go ahead and write our formula down. And here's our cone right here. We're going to use total. Pi RL plus pi r squared. Okay? And what we have here is, remember our cylinder. Take a look at the cylinder right here. Look at this formula here and this one and compare. We got 2 pi r and then pi r. That's just half the cylinder. And we have our L instead of height, because this we'd have to push it over and make it a right cylinder. Or I could have done this and found my height that way. And then 2 pi r squared. The reason why it's 2 is because we have base 1 and base 2. Here we just have base. Let's go ahead and plug in what we know. And I know my pi. It's pi. It's a very fancy long number. R is 8. 17 is my L. Plus pi 8 squared. And we can put this in the calculator. So I got 64 pi plus 80 plus 56. So we're just going to go ahead and knock it out. 8 times 17. Now, did you notice I didn't do something? I didn't put in the pi in the calculator. And I'm going to do plus 64. All right. So I got 200. 200 pi. Now, the reason I didn't put pi is a couple of reasons. One, I have to do that shift and go all the way to the bottom and put it in there. And that's just a lot of work when I could just attach it to the end. See the pi down here? But if I wanted exact, I would have to put it in the calculator. So I'd have to put shift pi. And my Casio will do that. All I have to do is hit the F to D button. And I got 628.3 square inches of surface area on this party hat. All right, moving on. Third example, a sphere. Now, a sphere is a lot more complex to prove on the formula. We'd actually have to use some calculus if we want to get actually kind of precise with infinitesimal circles and stuff like that. But we're not going to play that game. So you notice that there is no lateral surface area for a sphere. It's total. It's the whole thing, baby. So what we're going to do is surface area is equal to 4 pi r squared. And again, we're not going to get into deriving that formula. We can kind of do the Archimedean way of doing shadows and things like that, but I will see what kind of time we have on that. So 4 pi r squared, I'm just going to plug it in. Guess what? My r is not 50. It is 25. Right? It is 25. 25. Bingo. So we got 4 pi 25 squared is 625. But I'll show you how to do this in the calculator. Because once you do this, this is what I'm looking for. I'm happy right here. You're going to see that on your test if I ask you a basic question like this, but you know we're not. We're going to do something evil. So I'm going to do 4 times, and your Casio will do this. Watch this, 25 squared. Boom, 2,500. So we got 2,500 pi. And if I wanted approximate, you just put that 2,500 pi in the calculator and finish. Alrighty guys, that is it. I will do composites next.